This video discusses even and odd functions. The term even is used to describe functions that are symmetric with respect to the y-axis or some vertical line. The term odd is used to describe functions that are symmetric with respect to the origin. When determining whether the equation of a function is even or odd, we're going to do a single test and then interpret the results. That single test is to replace x with negative x. A function is even if f of negative x equals f of x. So basically, we're going to replace x with negative x. If we clean it up and get the original, then the function's going to be even. A function is odd if f of negative x equals negative f of x. So if when we plug negative x in for x and we clean it up, if we get negative 1 times the original, it's going to be an odd function. If it's not either one of those two very specific situations, then the function is neither even nor odd. So let's determine whether g of x equals 5x minus x to the 9th is even, odd, or neither. We're going to take a look at g of negative x. So we're replacing all the x's with negative x. And then we'll clean it up. Positive 5 times negative x, negative 5x. A negative x raised to the 9th. That's going to be negative x to the 9th. And then we can simplify that a little further and rewrite it as negative 5x plus x to the 9th. Now that we've simplified it, it's time to determine whether it's even, odd, or neither. So we start by looking at the original. Is that exactly the same as the original? Definitely not. So it's not even. Then we want to see, is that negative 1 times the original? Well, sometimes we can look and tell, and sometimes we can't look and tell. Sometimes when we try to just look and tell, we make a mistake. So what I like to do is over on the side, see what does negative 1 times the original look like. Just do a little side work so I know what it would have to look like in order to be odd. So negative 1 times the original would be negative 5x plus x to the 9th. Is that what we have over here? It sure is. So this is g of negative x is indeed equal to negative g of x, which tells us that this function is odd. Let's try another one. H of x equals x to the 5th minus x to the 3rd over x to the 7th. We start by finding h of negative x. We're replacing all the x's with negative x. Negative x raised to the 5th. It's going to be negative x to the 5th. Negative x to the 3rd. Negative x to the 3rd. And negative x to the 7th. That's negative x to the 7th. We can simplify the numerator a little further, rewriting that negative x to the 5th plus x to the 3rd over negative x to the 7th. We've simplified it, so let's start comparing with the original. Does it look like the original? No. Well, let's determine whether it's negative 1 times the original. I'm going to do my side work, figuring out what does negative 1 times the original look like. So that's going to be negative 1 times this fraction. Remember, when you're multiplying a fraction by a whole number, you want to take the whole number and put it over 1. When we multiply straight across, we're going to get negative x to the 5th plus x to the 3rd over a positive x to the 7th. Frequently, when students look at this example, they're like, oh yeah, that's negative 1 times the original, because they've seen that every single sign has changed. But that's not the case. With a fraction, every single sign doesn't change. Either the numerator changes sign or the denominator changes sign, but not both. So this is not negative 1 times the original. Before we decide that it's neither even nor odd, odd's definitely out, but before we rule out even, there's one more algebraic trick we can try. We can multiply the numerator and the denominator of the fraction by negative 1. This is similar to the move that we do with symmetry, where we divide all terms by negative 1. But here, we don't have an equation. We know not to mess with that h of negative x notation. This is a legal math move because we're multiplying the numerator and denominator of the fraction by the same number. So really, we're just multiplying by a fancy form of 1. When we do that, we're going to get x to the 5th minus x to the 3rd over a positive x to the 7th. When we compare that to the original, look at that. It is the original. H of negative x is equal to h of x, which tells us that this function is even.